Hello, my name is Devon Raleigh, and for this assignment I chose to use the dd command to acquire a hard disk image under Fedora 19. So for this particular exercise I chose to use an ancient 4 gigabyte Quantum Fireball hard drive pulled from an old iMac. I'll also be using a USB 2.0 to parallel ATA serial ATA adapter made by Ultra. So the first thing you'll notice is on the Fedora desktop, the hard drive is automatically mounted, and we definitely don't want that. So we need to unmount the hard drive before we can take an image of it. To do that, all you have to do is right-click on the drive, click Unmount Volume, and you'll notice that the little eject icon has disappeared, which is a good indicator that the drive is now unmounted.
Hi, I wanted to pause here for just a second and clarify something that Devon said in this tutorial, and then Devon will continue on. But the first thing is, so he just described that a drive being mounted. By default, if we're using something like a live CD, the drives would not be mounted, but they would be displayed. In the video, in the tutorial that Devon is showing us right now, his drive actually was mounted, so he did go through and unmount that drive. In a computer forensics investigation, you wouldn't want this drive to ever be mounted because it could potentially change some of the modified access create dates. Maybe not the create, but it could change some of the modified access dates. And then I wanted to go through one other quick thing here with you, a way that you would mount the drive. Let's see. So a way that you would want to mount that drive in forensics, so you must mount the forensic image to access the file system. When you mount it, it makes the drive accessible, so then you can take your image, as Devon will show us in a moment. But the way that you'd really want to do that, you'd want to make sure that you do it in a read-only option. So that's where we have this. We'll go through what everything is saying here. So first, in Linux, we have mount as our command, and then we're saying the T specifies the type of image. So they're using vfat, which is the same as fat. You'll see that's pretty common in there. And then our switch O, that's saying which options we want, and the option that we want is read only. That's extremely important when you're doing your Linux investigation, that you have it read only, so that you're not changing any of those Mac that modified access create dates, because that could really throw lots of doubt into the validity of the evidence and who did it and everything like that. And then the rest of this command loop is just saying interpret the images if it contains a file system. And you see we're doing it in a DD format. That's our data dump. And then we're just saving it to some folder called image. So that's it. So I'll let Devon continue on. Just wanted to put that clarification in there. Thanks.
So moving on to our command prompt, I decided to create a new directory to store the image files that I'll be taking from that hard drive. So I'm just using the mkdir command to create a new directory named forensics under my home directory. ls command to show that that directory now exists. Then I simply moved into that directory using the cd command, mkdir to create another directory underneath that one called case1. There's a directory listing to show that that directory does exist. cd to move into case1, and print working directory shows that we are in fact in the case1 directory under forensics. Now, earlier I did verify that the hard drive is mounted at SDB. So that's what we'll be using in conjunction with the dd command. Now, in order to use dd under Linux, you'll have to run the command as an administrator. So the full command in this particular case is sudo, which allows us to run dd as administrator, dd command, if for input file equals /dev/SDB. That's the location of the hard drive itself. And the book recommended that we split the image into multiple images. It also recommended that if you were going to use those images with a Windows-based forensics tool, to use the -B option to append a lettered suffix to the end of those files, and to set the image size to 2000 megabytes. The last little bit there, image underscore SDB dot, is simply going to be the first part of the file name. The split command will actually append a lettered suffix to the end of that. So, for example, image underscore SDB dot AA. So we hit return, and it asks for our administrator password. And if all goes well, you should see something similar to the output here. This took about 6 minutes on a 4 gig hard drive. A simple directory listing shows that we have 3 images taken from that hard drive, image underscore SDB.AA, .AB, and .AC. Now once you have those images, you want to verify and validate that they are identical to the hard drive that you took the images from. And for that I chose to use an MD5 sum. Now I got a little bit ahead of myself here and actually created an MD5 underscore SDB.txt file to hold the MD5 sum, but you don't actually have to do that because the MD5 sum command will create that file for you. We do have to run this as administrator as well, so sudo MD5 sum /dev/SDB, because we're taking an MD5 sum of the hard drive itself, so it does still need to be connected to your acquisition system. And we're going to store the output of that in MD5 underscore SDB.txt. Once we've entered our administrator password and the system has created that MD5 sum, we'll want to do the same thing with the images that we took earlier. And to do that, we'll use sudo cat image underscore SDB dot asterisk. What that's going to do is look for any file named image underscore SDB dot something and concatenate all of those files together. It'll actually treat all 3 image files that are in this directory as one file. And we'll pipe that into the MD5 sum command and append the output to MD5 underscore SDB.txt. So it'll basically just add the output from this command to the output that already exists in that file. And again, this is just showing you that that file exists and has been stored in the same directory that we're working in. And we can view this file in any number of text editors, word processors, whatever you want to open it in. In fact, you could just echo the output directly on your screen. I like to use Nano. It's simple, easy to use. Here you can see that the MD5 sum is identical for both the hard drive and the images.